Hey everyone, I'm Alex from Openfort. In this video I will talk about new release of the EntryPoint v9 and I will cover a new feature. But before we are diving to technical conversation, I want to do a quick recap. What is this EntryPoint and account abstraction? EntryPoint is a part of ERC 4337 standard. Account abstraction allows user to utilize smart contract wallet or smart accounts with different features like batch transaction, custom authentication, and gas sponsorship. So the core of the ERC 4337 is the Paymaster contract. It's basically a singleton smart contract on each network that process user operation or bundle transaction from the smart accounts. So basically we can think about like a kind of orchestrator. The entry point basically validating user operation, enforcing the paymaster data, and execute user call. The new EntryPoint v9 has just been released and bringing improvements while maintaining backwards compatibility. It means that no ABI changes were introduced in the v9, mean the external interfaces functions remains to the same as a version v8. So existing integration won't break. However, the EntryPoint v9 includes important enhancement for the performance and new capabilities, especially around the paymaster and how the user operation hash are computed. In this overview, mainly I will be focused on the new feature of the paymaster in the EntryPoint v9. I will show how it supports for the paymaster signature and enabling parallel signing of the account and the paymaster for the faster building of the user operation. And I will show the get user operation hash function, how it's implemented and how it excludes the paymaster signature from the hash computation. Let's dive into the main feature of the v9, the paymaster asynchronous signature and the updated user operation hashing and what it means for the developers. In the previous version, if we wanted to sponsor the user operation, it was needed to populate the paymaster data with valid data for the paymaster and approval signature from the server to authorize sponsoring. After we populate completely the user operation, it was calculating the user operation hash and account was signing and we was adding the signature of the account. So basically this flow is sequential and synchron. In the EntryPoint v9 fixes this by allowed paymaster to sign in parallel with the account. So basically it's saving for us time and we can do it asynchron. How the new feature of the paymaster signature working, you also can find in this documentation that ERC 4337 team published. Under v9, the paymaster and data bytes array can carry an embedded signature for the paymaster. The EntryPoint and the paymaster contracts use a simple convention to achieve this. The magic happens in a special 8-byte magic constant. It's use a marker to indicate a signature is present. In code, the constant defined as a paymaster sig magic you can find in the user operation lib, and which the first 8 bytes is the ketchup 256 of the hash of the string paymaster signature. The final paymaster format in most completely case you can find in this document, and this is exactly how it should look if you want to use with the paymaster signature asynchronous flow. Each component is concatenating in order, so let's break down what does it mean. So this is the user operation, how it's look completely. We're gonna break down the paymaster data. So basically the first 20 bytes is the address of the paymaster. Then we are include verification gas limit and the post of gas. It's each 16 bytes. And the paymaster data, it could be n bytes. In this example, I just put the timestamp of validation. Then we have the paymaster signature, 65 bytes or 64. Then we must have to concatenate with this magic bytes. 2 bytes is for the signature length, it's the uint 16, and the paymaster signature magic that we seen before in the UserOperation lib. This is basically how it will look in the complete way. The bytes in the paymaster data we should concatenate exactly in the same way that the entry point will understand that we used with the feature of the asynchronous signing of the paymaster. Basically, we are adding 10 bytes more for the paymaster data that entry point will understand that we are used with the feature of the asynchronous signature. A small security note, so the magic constant and the length prefix of the signature ensure that the paymaster signature cannot be confused with arbitrary data. So the EntryPoint v9 code that check if the magic constant is present, the indicated signature length is sensible. Otherwise, it will revert the operation for invalid format. So it's prevent a scenario where malicious actor can enlarge the paymaster data and, for example, make a gas grifting attack by adding more data to the paymaster. To support this feature, the EntryPoint hashing the user operation need a slightly modification in the implementation of the v9. So the goal was exclude the paymaster signature bytes from the hash calculation. A quick reminder, in the EntryPoint v8 the user operation hash was computed by hashing all fields of the user operation struct, include the signature of the paymaster. The paymaster data was treated as a byte array and was fully included in the hash. This means that if one tried to stuff a signature inside the paymaster data, it would unfortunately change the hash. Let's quickly walk through the getUserOperation hash function. The implementation doesn't change so much, but inside this wrapper we have the helper to encode the user operation hash, and the magic happen in the paymaster data catch-up. So basically here the helper get paymaster signature length. We are indicating if we used with the asynchronous flow. Basically in this helper we are indicating if the paymaster was using with the parallel signing. So here, as you can see, we are checking all the magic values that I mentioned before. That's basically showing us if we add this addition 10 bytes to flag to the entry point that we exclude the signature of the paymaster from computation of the hash. So this function basically helps to the entry point to understand if we need to exclude the paymaster signature from the computation of the user op hash. I created this simple test to show the functionality of the new feature. So here basically I'm getting the fresh user operation, then I'm populating the necessary fields, and after I'm creating only the paymaster data, and I'm adding in addition the paymaster signature magic. After that, with this helper, I'm calculating the user operation hash, and in the end I'm signing with the private key of the owner of the account. After the owner of the account signed the user operation, I'm creating again the paymaster data, but in addition I'm adding the length of the signature. Right now it's 0. Then from the contract of the paymaster I'm getting the hash and signing with the private key of the manager of the paymaster. Then I'm concatenating all the information together. So basically, as you can see, inserting here the paymaster signature, then I'm indicating exactly what the lengths, and we are adding the paymaster signature magic. So basically all this, it's the 10 addition bytes. And also I did example for how it was working before without this new feature. So basically you can see if we doing the same flow, creating the paymaster data, signing the paymaster data, populating the field in the user operation, and then in the end, basically we are signing the all user operation with the owner private key. So basically the main difference between synchronous signature and asynchronous signature, that we excluding the paymaster signature from calculation of the user operation hash. This test already working with the implementation v9 and the new feature. So let's run this test and we can validate this test passing that basically we sign the user operation hash with the owner before basically we sign the paymaster data. And for the low level bytes lover, I'm breaking down here how basically the paymaster data looks in asynchron and synchron way that we are signing the paymaster data. So as you can see, the difference here, it's only these 10 bytes. Here also you can see how I'm breaking down the full data just to understand how the struct will look. And also I created very simple benchmark that basically showing us the performance and difference between asynchronous flow and synchronous flow. So I'm just basically crafting the user operation there and running 50 times 50 loops just to measure the average of the time. So as you can see, the difference is the almost 50% if you're using with asynchronous flow, parallel signing. So basically it's decrease the latency and the off-chain crafting of the user operation can be right now much faster. On the paymaster implementation smart contract, you also somehow need to indicate if you use with the new feature of parallel signing. In the Openfort implementation of the paymaster, I'm using with the same helper of the EntryPoint to indicate the signature length, and if we add in addition the magic 10 bytes. Okay, so then let's wrap up everything together. EntryPoint v9 brings valuable enhancement to the ERC-4337 account abstraction layer without any breaking changes to the interface from the previous version v8. So developers can upgrade to the v9, but you need to take advantage of parallel signing for the paymaster data and accounts, which improves the latency of crafting user operation. Just to not make you confused, the EntryPoint version 9 support asynchron and synchron signing together. So basically you can choose which flow you want to craft your user operation. Okay, so I think I covered everything about the new feature of the parallel signing. Of course, big thanks to Infinity's team that creating a huge work behind of the ERC-4337. All relevant links I will add in the description of this video. And I think we're done here. Thank you very much. I'm Alex from Openfort, and see you in the next video. Ciao, ciao.